The next experiment is design and implementation of IIR filters of different types: Butterworth, Chebyshev, type 1, type 2, and various types of filters you can design: low pass, high pass, band stop, in order to meet the given specifications. The tool used is MATLAB Simulink here. Okay, let me explain the procedure step by step. So step 1 is you have to go to the MATLAB, then you have to click on apps. Okay, after clicking on apps, you have to select the drop down box, signal processing and communications. Then you have to select the filter design and analysis tool. You can see here filter design and analysis tool is being selected. Okay, you are going to signal processing and communication block, and then you are selecting filter design analysis. Okay, you have to select on that. Then step 2 is you have to design your own filter prototype, IIR or FIR, anything. Okay, so you can click on Butterworth or Chebyshev, and then you have to click on low pass or high pass or band stop. Okay, my suggestion is go for all types of filter design. Okay, you have to give the proper specifications or proper parameters, and then you have to click on the design filter button. Now you check here. In this example, they have selected low pass filter, and the type of filter they have chosen is Butterworth. Okay, you can see they have clicked on IIR Butterworth, and then they have given the order as 10. Okay, and unit of frequency is Hertz, and Fs they have given as 1600. The cutoff frequency they have given as 400. And once you click on design filter after giving the proper specifications, your filter is designed here. Here the cutoff frequency is 400. So till 400 it is passing, after 400 it is blocking. Okay, so the filter is designed. After going for filter design, what you have to do, you have to export the designed filter to the workspace through the following steps. Okay, so you have to go to File, Export, Export to Workspace, Export as, select object, variable name, the numerator, and then click on Export. You check here, Export to Workspace. You have to export to Workspace, export as objects, then the filter name is IIR LPF. Then you have to click on Export. Okay, so the filter is exported to your MATLAB command window or MATLAB workspace. Okay, so the filter is exported now into the MATLAB workspace. Then what you have to do, you have to just write a code for this low pass filter IIR which you have designed. So you have to choose Fs as 1600 because we have chosen the same Fs in the filter design. So same Fs and same Fc you have to write here. Okay, then they have chosen dt as 1 by Fs, that's the time period or the time interval. Then t is varying from 0 to 0.1 with the interval dt. Okay, then you are defining a signal. Let us say x is equal to 2 pi into 350 into t. The signal frequency is 350 here. Once you write the equation of the signal, you are going to pass the filter onto the signal. So you have to write a code for it. Y is equal to filter. There is an inbuilt function called filter. Filter within bracket IIR LPF comma x. So your signal is ready and the signal is passed through this IIR LPF. Okay. So since it is a low pass filter, definitely the signal will be passed through this because the cutoff frequency is 400 and the signal frequency is 350. So it is satisfying the low pass filter condition. If you give if the signal frequency is more than this Fc, then the signal cannot be passed through the filter because it's a IIR filter. Okay, so now you can export your filter. Okay, and you can apply the filter onto the signal. Now you can see both the filtered output and the signal. So you can write a command plot t comma x comma t comma y. So that means time versus the signal comma time versus the filtered output. The filtered output is y and the input signal is x. Okay, then legend x comma y. You can name the signals as x comma y. X is the input signal, y is the signal after filtration. Now you check the output. Okay, x is blue color, y is green color. Okay, so the filtered output is green. Green one is the filtered output and initial signal was x. After filtration, the signal is your y. That's what is plotted over here. Okay. Now this is a low pass design. You can change the values and you can go for a high pass, band stop. You can change, instead of Butterworth, you can click on Chebyshev and design a Chebyshev filter also. Okay. So what you have to do, you have to first design the transfer function by giving the appropriate specifications. Then you have to click on design filters. After clicking on design filters, your filter is designed. After that, you are exporting the filter to MATLAB workspace. Then you have to define any signal. You can see here in the command window you need to write all this. Okay, so you have to define a signal, and your designed filter, whatever filter you have designed, that you have to apply onto the signal, and then you can plot both the input signal and the filtered output, and you can check the output over here. Similarly, you can design IIR band pass. Okay, they have shown IIR band pass. Okay, and you have to specify the order. You have to give 2 cutoff frequencies for band pass. Okay, this and FS you have to give, and you have to click on the design filter button. You can see the band pass filter is ready. Now after this band pass filter is designed, again you have to write the program for it. FS they have given 2000, FC they have given 300 to 500, whatever specification you have given here, in the command window you have to give the same specifications. Okay, otherwise it will not run. So dt is 1 by fs, so you are writing the signal and you are giving the signal equation also, and you are passing this band pass filter onto the signal x. Okay, and then you can see the filter output as well as the input signal t comma x comma t comma y you can give, and you can check the filtered output over here. X is blue one and y is green one. You can check the filtered output. The signal is passed through a band pass IIR band pass filter. Okay. For FIR also, you can go to MATLAB, then apps, then you have to select the drop down box, then signal processing and communication block. Okay, then you have to select filter design and analysis tool. Similar way you have to do. You can see here, this is the signal processing and communication block. In that filter design and analysis you have to click on. Okay, after clicking that, what you are doing, you have to design your own filter prototype FIR, low pass, high pass, band stop, any type of filter can be designed over here. Okay, so you can see they have chosen low pass filter. Okay, then instead of, there are 2 options, IIR, FIR. Click on FIR window, you specify the order, and the window used here is rectangular window, and the frequency unit is hertz. Okay, and the sampling frequency they have given as 1600, cutoff frequency 400. Okay, and you have to click on the design filter. Your FIR filter is designed now. Then what you have to do, you have to apply this FIR filter onto a signal. Okay, so for that you have to export the filter to your workspace, MATLAB workspace. So you have to follow the same procedure. Okay, after clicking on this design filter, you have to export it to the MATLAB workspace. You have to go to File, Export, Export to Workspace, Export as Select Object, variable name you give the name. Okay, FIR filter, you name it, give some name, then click on Export. Okay, then you have to write a code in command window. So you have given FS as 1600, FC as 400, DT is 1 by FS, you are giving the time interval, writing the equation of the signal, then Y is equal to filter FIR LPF. So you have designed a low pass FIR, so you can give the name as FIR LPF, comma X, so that this filter is applied onto the signal X. Then you can plot the signal as well as the filtered output. Okay. So the cutoff frequency here is 400 and your signal frequency is 350. Definitely the signal will be passed through the filter. Okay, and you can check the output. You can check the output, verify the output, and design all other types of FIR filter. Show us all types of outputs. Thank you.